this computer. All right. Share screen. Share. Control. Oh. Okay, so far 20 students, so we wait for another 3 minutes. All right. We wait for another 3 minutes. Wow, so happy. Huh? Who is laughing? So happy. Huh? Who is laughing? Actually, I hope all the students can be punctual next time, you know. So I don't need to wait for some of the students so we can finish the class on time, you know. Who is opening the music? Can you mute your music? Yeah, please mute your music. Yeah, this is not a music class. This is a drawing class. You know, not art drawing, but engineering drawing class. All right. And today will be the last online lecture. All right. Who is open the music? Can you mute your music? So we will start in 1 minute. All right. We will start. I don't want to wait anymore, you know. So far 26 students. Supposedly we have 39 students. Can someone mute your mic? Is it who? Yuan, is it? Is it Yuan? All right. I think it's almost 2:05 already. Me. So happy you listening to the music. I'm not teaching music, you know. So, all right. So I start. Yeah, Rita. Rita is here. So can all of you see my screen or not? If can, then just reply in the chat box. Yeah. Can you see my screen or not? All right, then I just start. I just start. Rita, are you here, Rita? Can you hear me, Rita? I haven't received your assignment 1. Could you please finish it and submit by today, if possible? Because I don't want to give you a 0 marks, you know. I don't want to fail any student. Otherwise, I need to write a report, you know. Assignment 1. When you submit? When you submit? Is it by email or Times? You submit to Times or you submit to my email? You submit again. You submit to my email. Can you? You submit to my email. You know my email, right? Now you send to my email. You don't need to send to Times anymore. Just send to my email. All right. So I start. Okay, today we are going to do the lecture 11 and 12. So today will be the last lecture, you know. So no more online lecture anymore. So this lecture are according to the MLO number 3. Assemble parts model into complex and interconnected solid models. So this is my slide. Okay, for lecture 11, very short and very simple, all right? Very short and very simple. Okay. Lecture 11 is the basic assembly and standard made. Oh, what happened? What happened? Wait lah. Open again my slide. 11. Wait lah. It's opening. All right. So lecture 11, basic assembly and standard made. This is a very short lecture and very simple. And okay, we have now completed the basic features of part modeling, and it is now time to begin structuring more complex models in the form of assemblies. Recall that an assembly is the collections of parts that are connected using mates or constraints. Before we work in the program, let's first discuss the different type of mates. I think you have done it in your tutorial number 6 last week, right? Very simple. Last week we used coincidence, parallel, and concentric. I think we only used these 3 last week for tutorial number 6, coincidence, parallel, and concentric. All right, very simple. Okay, mates. There are 5 standard mates that can be used to construct an assembly model. The first is a coincidence, which defines coincidence between 2 entities, point to points. The first one, they must lie on top of each other. Number 2, point line. The point must lie on the line. Number 3, point plane. The point must lie on a plane. Number 4, plane. The planes must be the same, and etc. Okay, the next mate is parallel, line to line. The 2 lines must be parallel in 3D space. Plane to plane, the 2 planes must be parallel, not the same as coincidence. There will be some distance, right, in between the 2 parts. Okay, the next one is a perpendicular mate. Line plane, the line must be normal to the plane, and plane, the 2 planes must be perpendicular to each other. I think this one very simple. Tangent mate, cylindrical surface plane, the plane must be tangent to the circular surface, and cylindrical surface to cylindrical surface, the 2 cylinders must be tangent to each other. This one also very simple. Concentric mate, this is used with 2 cylindrical surfaces to represent that their respective axis of revolutions must be coincident. Example, placing a bolt into a hole. This one simple. Distance mate, you can add distance mate between the face, place, and line. You must type a distance value in the distance box in the mate property manager. All right, let me show you my SolidWorks. I think this one, you have done it already. Let's say I open the assembly file. Where's my assembly file? Let's say this one. I think it's here. Let me edit the feature. This is your distance, all right? And this is your angle in between 2 parts. So I just cross this one. Continue my slide. What happened? Okay. Okay, just now I have shown you a distance box, okay, in the mate property manager. The default value is the current distance between the selected entities. Angle mate, similar, you can add an angle made between the face, place, and line. I think this one is plane, you know, not place, plane. Okay, you must type an angle value in the angle box in the Make Property Manager. The default value is the current angle between the selected entities. This one also very similar. Log mate. Okay, a log mate maintains the positions and orientations between two components. The components are fully constrained relative to each other. This log mate is similar with fixed. All right, fixed. A log mate has the same effect as forming a subassembly between the two components and making the subassembly rigid. All right, we finished lecture number 11. So far, any questions? If yes, you can type in your chat box, or you can open your mic, you can talk to me. If no, then I will continue lecture number 12. All right, lecture number 12. No, sir. Yeah, very simple, this one. A piece of cake. All right, so I open 12. Okay, lecture number 12, a bit tough. All right, a bit tough. I think I need to show you some demo. All right. Otherwise, no student can understand, because this is related to the advanced and mechanical mate. This one a bit tough. All right, I will show you some example. I will do the hands-on. Don't worry. All right, I will do the hands-on. Okay, lecture number 12 is the advanced and mechanical mate. This one a bit tough. All right, a bit tough. So there are 1, 2, 3, 4. I think advanced mate got 4, but we got also mechanical. Okay, we got symmetry with path mate, linear to linear couple. All right. Okay, the first advanced mate symmetry. Symmetry. Okay, make two parts to be symmetry with respect to a plane or planar face. Select two planar faces, lines, and points in this mate, but the selections should be of the same type. Means planes only or points only. Two planar face of links are set to be symmetry with the right plane as the reference. Okay, this one I show you the example. So I open my SolidWorks. Give me a moment. I open already. Don't worry. Okay, so I close this part. Don't save. Okay, so I open a new assembly file. New assembly. All right. So I go to import my part A. Oh, sorry. I should call in part B first. Actually, it's the stem now. A or B. It's okay. Don't worry. A and B. All right. Just in B place, very simple. Okay. Set to MMGS. All right. Let's say I want to put this apply into this cavity symmetry, left, right, or top and bottom. So you can see how I do by using symmetry. Okay, I go to switch on this thing first. Okay, plane. You see, there's a middle plane here for this plane. All right. So I go to mate. All right. Go to advanced symmetry. So where is my symmetry plane? So this is my symmetry plane. Okay. Relative to this face and this face. All right. Go to the center really. And I want to do one more for here. Advanced symmetry plane here, this one. To bottom and top. All right. And one more, but this one I use standard. I use this surface and this surface. Coincidence. All right. Okay. So now you can see it is sitting inside the cavity at the center. All right. If you don't believe, you can do a measurement. Don't worry. Okay. Go to evaluate, measure. This one set to mm. All right, set to mm. Okay, then I want to measure this surface to this surface. Okay, the distance is 170 mm. All right, then I also want to measure the left-hand side. This one and this one, is it the same? Yes, 170 mm. Okay, so for any questions? Then I also can measure here. Sorry. Select again, go to measure, select the surface and the top surface. What's the value? 80, 80, right? Then I also measure the bottom here. This one and this one. Let's see, is it 80? Yes, 80. So this is called symmetry. So for any questions, this one very simple. This is called symmetry advanced mate. All right, if you got question, you can type in the chat box or you can open your mic, speak to me. Okay, so now I close this one, don't save. All right, this is very simple. Then I continue my slide. Okay, mate symmetry, very simple. Okay, advanced mate width. This is quite similar with symmetry, quite similar. All right, but this one is the width made two planes such that they are at equal distance from the selections. With selections, two planar faces parallel or not parallel in between which the component is to be placed. Type selections, two parallel or non-parallel faces or one cylindrical face. Yes, anyone talking? Anyone? If nothing, can you mute your mic? Yeah, just mute your mic.
You're very shy, is it?
Who is it? Who is it? Who is talking? Then I continue. The tab. Please mute your mic. Don't disturb other students. Please. Okay. The tab will be placed at the same distance from the width selections. If the component to be placed is having planar faces, then you can invert the mate selections. Okay. Let me show you. Let me show you. Then I open my SolidWorks. You can see my SolidWorks, right? Anyone? Can you see my SolidWorks? If yes, then you type in the chat box. Just say yes. Let me see. Yes. All right. Thanks, Mr. Fu. So I continue. So I open a new assembly file. All right. Then I call back the two parts just now. But this time I'm not using symmetry. I use width. All right. Width. These two parts. You see how I do. Okay. Go to assembly, mate. All right. Advanced width. Okay, if you use width selection, you don't need any mid-plane anymore. You don't need the mid-plane. In your width selections, you go to select the bigger part. Okay, the bigger part. So this cavity has a bigger part, no? This surface and this surface. Tab selections, the smaller part. This surface and this surface. You see, you go to the center. Go to the center. Then I click OK. Then I do one more again. I go to width. Okay. The bigger one is this one, top and bottom. Sorry. This one. All right. And tab selection is a smaller part. Top and bottom. You see? You will go to the center automatically. Very easy. All right. Then I do one more mapping, which is using standard. This surface and this surface. All right, okay. So let's do one checking. I go to evaluate, measure. I just measure one surface, enough. One distance is enough. See, 170 mm. Same as just now, the symmetry mating. So any questions? Very easy, right? Okay, now I close my file. Don't save. All right. Open my lecture notes. Okay, advanced mate, path mate. Okay, path mate a component vertex to a path. Component vertex, a point, 3D point, midpoint, select a path, open or close loop. The mate places a selected vertex as at a random, mostly nearest from the current location on path. You can even sketch the path in the assembly as well, which you need to do in the following example. Draw the approximate curve shown, 2D or 3D. All right, let me show you the example. File, open, sorry, file, new, assembly. All right, then I go to import. Which one really I forget? Yeah. Yeah, this part. Yeah, I import the fixed part first. All right. Remember the first part that you imported always is fixed. You will never move on. All right. Remember this one. And I go to import another part. Import another part. Where are you? Yes, this one. All right. The lower. All right. I think last week we have learned how to do a slot. All right. Slot. Let's say I want to insert mapping this one by using slot. Go inside this slot. All right. I go to mate. All right. First of all, I want to make it coincident with this surface first. Standard, not advanced. Coincidence. All right. Go inside already. But you see, it's not inside the slot. All right. Then I do one more. Mapping. Go to mate. Slot is inside. Where is slot? Mechanical. Yeah, slot. This one. All right. So I select this surface and this slot. You see, selected entity is not valid for the current mate type. For your information, slot mate sometimes work, sometimes cannot work. All right. In this case, the slot mate is not working. So how? You need to use another way. So I show you another way. I show you another way. So I delete the mate, this one first. Okay, delete this one first. Then I drag it out. All right, drag it out. Let's say I use advanced path mate. All right, this one, path mate. Coordinate vertex, the center of this cylinder. You see this point? Sitting at the center of this cylinder. All right, so I just point to this vertex. Okay, path. We don't select straight away here. All right, because you see, you know why? Because this line selected, but the rest of the line are not selected. So I go to delete this one, but I go to selection manager. Then I go to this curve, point to this path, then click OK. All right. Then I click OK again. OK again. Okay. Now we see what happened. You see what happened? Okay, you see? E is moving within a slot, but it's rotating. You see? Rotating. So incorrect. All right, incorrect. So what I need to do is I go open again the mate, edit the mating again. All right, so I go to row control. Row control, I don't want it rotating. All right, go to up vector. Let's say I select this line. You can select any line, you know. This one also can, this one also can, this one also can. All right. Let's say I don't want this direction. How about X? Not this one. Yeah, this one, Z. Then I click OK. OK again. Then we see what happened. Okay, we see what happened. E is moving within the slot, But what happened is, you see, you see this axis, this line is rotating, you know. It's rotating. When I move it translationally, it's rotating. I don't want it rotate like this. So I can do one more setting. Okay, I go to edit the path again. This one, pitch yaw control. Who is it? Okay, follow the path. Then I click OK. OK again. So now you see what happened. You see, you see, it no longer rotate. It moved very nicely. So this is what I want. All right. So far, any questions? Okay, let's see what's the questions. Sorry, sir, have you selected the whole path again? Path, I mean, how you select? Okay. How I select? Let me do it again. Let me do it again. So I delete this path mate. I delete it. Okay, you see one more time. You see one more time. Go to mate. All right. Go to advanced. Go to path mate. Okay. Component vertex. Where I want to choose the center of this cylinder. This point. Can you see this point? Okay. Then in path selection, I don't want to select here, but I go to click this selections manager. All right. Then I select this curve and select this curve. Then I click OK. You see, it go to the path itself. All right, clear. So any questions? All right. Okay, actually in SolidWorks, right, you can calculate the length of this curve, you know, the path. Okay, let me show you. Go to evaluate, measure, this one. Sorry. I want to measure this path. How long it travel? Okay, the total length is 92.376. Actually, for straight line, who is it? Can you mute your mic, please? Okay, it's very easy to measure or to calculate the length of a straight line. But for this curve, right, it's not easy to calculate the length of this curve. All right, I think in your maths, SPM or O level, I don't think you have learned this one. I think we only learned this one in further pure maths, you know. Further pure maths curve length. Let me show you how to calculate the length of a curve. This one very tough one, this one. Yeah, this one. Okay, this is the equation, arc length. Okay. This equation seems simple, but when you substitute the dy dx inside into this square root, I can tell you most of the case, the equations cannot be integrated, you know, because of this square root. Then you need to use the numerical method to calculate the curve length. All right, I think this one you learn only in further pure maths, you know, A level or STBM. In normal maths T, A level or STBM, we don't learn this one, only in further pure maths. All right, so I continue my slide. So this is path mate. So far, any questions? If no, then I continue, try. So I just continue. So I close this SolidWorks. Okay, this advanced and mechanical mapping a bit tough. That's why I need to show you the demo example. Otherwise, I don't think anyone can understand, you know. Okay, so the next. So this is one done. Okay, advanced make linear couple. Okay, this applies to a translational relations between two components. Moving one component force the second one into the same or different directions and up to the same or different distance. All right, let me show you an example. So I go to File, New, Assembly. All right. Let's say I want to import 3 part. Where's my part? Yeah, this one. And then E, F, and G. Hey, sorry, E, F, G here. All right. All right. So this is my 3-part. Change to MMGS. Okay, I want this is moving. So I go to float it. But I want this part to be fixed. So this one I fix it. All right. Then I do concentric mapping first. Go to mate. All right. Standard. Okay, this one is multiple. Means I can straight away concentric these 3 parts. I don't need do one by one. So I click this one, then concentric. All right. From here to here. And here to here. All right. Okay. So I show you something. Let me do the standard assembly first. All right. Then the second one is the let me think about it. Yeah, I know already. Take it out. This one also take it out. All right. Okay, mate. Standard. This is the face. This is the face. And this is the face. Wait, it doesn't move. Let me check what happened. So this part G. I know why already. Mate. I do one more time. Standard coincidence. Solidity surface. I go to multiple. This one. Click these options. Multiple. This one. This one. And this one. All right. But only for positioning only. Means I just want to position them. I don't want to do the mapping. All right. Click this one. Then I click OK. OK again. Let me show you the cross sections. Maybe it's easier cross sections. Not in this way, but in this way. So 270. Yeah, just nice. All right. So these are cross sections. All right. But what you see is when I move this part, you see, I don't want to rotate like this. No, I don't want to rotate like this. I also don't want this part rotate like this. So what I should do is I go to switch on the plan. All right, switch on the plan. Then I do the mapping again. Go to standard, multiple options. All right. Parallel. 1, 2, 3. All right, like this. Then I click OK. OK again. Don't worry about it. I go switch off it. Then I switch on again. Yeah, you see, very nice. All right. Yes, this is what I want. So when I move it, it does not rotate anymore. All right. And then as you can, okay, let me tell you the length of this part is 200 mm. 200 mm. But I don't want this part move beyond here. And this part does not move beyond here. I don't want like this. So I give a maximum locations. So I can go to make. Okay. Advanced. Distance. This one. So I point to this surface and this surface. Okay. Minimum is 0. All right. From the start point. Maximum is the length, throughout the length. So 200. Then I click OK. OK again. So now I try again. I try to drag it out. You see? When I drag it out, right, it doesn't go beyond the part anymore. You see? All right. Similarly, I do for this one. So I go to mate, advanced width. All right. I select this surface, not this surface. I delete this surface and this surface. All right. So minimum is 0. Maximum is 200. Then I click OK. OK and OK. So now we check what happened. You see? So this is what I want. This is what I want. You see? When I drag this solid part, right, it will activate the second rod. All right. So far, any questions? This one a bit tough, you know, for advanced and mechanical map, a bit tough. Did you show us enable the plan for each plan? Okay, this one. You go to the eye, this eye, right? Switch on the plan here. All right, switch on the plan here. All right, but I haven't finished, because this is about linear coupling. Okay, let me show you the linear coupling, what that means. Okay. So I do one more mapping, mate. Once, then linear coupler here. This one, all right. So let's say I select this surface and this surface. And the ratio, let's say 1:2. Later I will explain to you what that means, all right? Then I click OK, OK. Okay, now you see the magic, you see the magic, all right? Let's say I drag this solid part, you see what difference? Do you know what happened? Anyone can spot the difference with the just now, with the previous one? Can anyone tell me? Okay, the ratio here 1:2, this one. Wait, okay, means when this solid part move 2 mm, this second part only move 1 mm. Or when I move this part 1 mm, the middle part, this one, when I move this part 1 mm, this solid part will move 2 mm. So which means this solid body will move faster than the second part. This is called linear coupler. We can assign the ratio. So far, any questions? Any questions from the floor? If no, then I continue. All right. But I think this one is not included in your tutorial or test. Don't worry. All right. This is just for your acknowledgement. So I close this one. File, close. Don't save. All right. The next. What's the next? Okay. Advanced limit mate. This one I showed you just now already. So test will still be only based on tutorial, right? Yes, don't worry. The linear coupler are not included in your syllabus, all right? Yes, for your acknowledgement. Yes, for your acknowledgement. All right, so I continue. Okay, the next one is advanced limit mate. This one I showed you already. Okay, limit the translation movement within a defined range. All right, assignment of the mate is same as of distance mate. In addition to this, simply enter a maximum and minimum limits. Okay, I done it just now already. Once make limit make for angle. This angle, same thing. This limits the angle movement within a defined range. Again, assignment is the same as standard angle mate. In addition, and the minimum and maximum range apart can move within the limited angle. This is just about the same with the distance. So now we go to the very difficult one. All right. This is very tough one. Mechanical mate. Okay. Got how many? 1, 2, 3, 4, 5, 6, 7. Got cam, got slot, got hinge, got gear, rack pinion, screw, and universal joint. I think universal joint you have done in your assignment 2 already, so I won't show you anymore this one. And for slot, I think you have done this in your last tutorial, so I won't show this again. All right. Okay. The first one, cam, mechanical cam mate. Okay, a cam mate is a type of tangent or coincidence mate. It allows you to make a cylinder plane or point to a series of tangent extruded faces, such as you would find on a cam. You can make the profile of the cam from lines, arcs, and splines as long as they are tangent and form a closed loop. Okay, what it means? Let me show you. Let me show you the example. So I go to File, New, Assembly. Okay. So I need to import the part. So what's the part I need to import? Wait lah. You see this one? Not this one, sorry. File, insert component. Oh, I just show you the assembly lah. All right, I just show you the assembly, easier. Hey, sorry, not like this. I just show you the assembly. Open. Yeah, I've done the assembly already. So is it much use showing in? No need, cause I computed. Don't worry. Wendy, don't worry. Just it's okay one when you also join. Okay, so I've done the assembly for the cam. So you see what happened once I turn this part right. Yeah, as long as it works, then okay already. Don't worry about that. Right. So I turn this point, you see what happened? You see? You see the pen move up and down. All right. So do you want me to do the assembly for you? For this one, do you want me to show you the demo how to assembly this cam? All right, so I do the assembly. This one a bit tedious. So I show you the assembly. All right, I show you the assembly. So I go to File, Close, don't save. So I go to File, New, Assembly. All right, so I go to, where's the part? Is it this one? Not this one. I think this one, yeah. Yeah, that's the pin. Right, I go to MMGS. So this part never move on, the pin, all right? Never move on. Then I go to import another part, which is, yeah, this part, all right? Yes, so I show you how to do the assembly, right? Okay, so first of all, I sample these two parts first, all right? So I go to use mate, concentric, this guy and this guy, all right? Done. And one more. I would like to use advanced, I think, well, width, all right? This guy and this guy, because this is the bigger part or longer, okay? This is the longer part. And then tab session, you select the shorter part, all right? This guy and this guy. You see? Go to the center already. Okay, and okay. So now I do a testing of whether it can rotate or not. Yes, it can rotate. All right. And then now I would like to switch on the axis. Yes, this guy. All right, switch on the axis. And then go to insert component. I want to insert the pen. Where are you, the pen? Not this one. Where are you? Hold on. Where's the pin? Cam. Yeah, this is the pen. All right. So I insert the pen. So let's see the magic. Let's see the magic. But I need to do a mapping first. This one mate, right? Standard. I use this axis and this axis. Okay. Okay, means this pen always parallel. with this axis, all right? Okay, but you see what happened now? This cam will touch the pen, all right? We touch the pen. And then what I need to do is, I do one more mating. Clear this one. I go to mechanical, go to cam path. Okay, which one is my cam path? This one is my cam path, all right? The cam follower, make sure you point to this point, all right? This point, okay, and okay. So let's see what happened, Let's see what happened. You see, very nice. Very nice. All right, very nice. You can even add a motor, you know. You can even add a motor. Okay, let me show you how to add a motor. Let's say I want to hide this part. Okay, hide the part. Go to motion study. I want to add the motor. Select this surface. Okay lah, 100. Then I click OK. Then I switch on back this pin. So let's see what happened. Start play from start. You see, very nice. All right, very simple, very simple. So far, any questions? If not, then I continue. Yeah, shall I continue? I continue. File. Yes. Yes, very fantastic. You know, very fantastic. That's why I want you to learn SolidWorks. All right. Okay. Next, what is it? So can be done already. Okay, mechanical mate, screw mate. Okay, a screw mate. All right, constrain two components to be concentric and also at a pitch relationship between the rotations of one component and the translations of the other. Translation of one component along the axis cause rotation of the other component according to the pitch relationship. Likewise, rotation of one component causes translation of the other component. So what that it means, you know, if I explain like this, I think nobody can understand. So I show you a demo. All right. So let's say I go to open my SolidWorks. Open. Let's say. Okay. Actually, I've done this assembly already. So I just show you the assembly lah. Otherwise, I need to spend my time do the assembly all along again. You know. Okay. Let's say this one. You see what happened? When I rotate this nut, you see what happened? You see? What happened? When I rotate this nut, it will come out, you know. It will come out. It will come out. So this is the meaning. All right, okay. And I can rotate it back. Go back to the initial positions. All right. And I can even add a motor, you know. So let's say I go to do motion study. Yes. Now, stop. Play. You see, very nice. All right. But what? Okay, you see what happened here? You see, when you touch this end, it cannot. When you rotate, it cannot go further anymore because there is no more thread here. How do I set the thread? I go to use this one, limit distance. Okay, very simple. I go to use limit distance, where the minimum is 0, means the nut at the beginning. Okay, maximum is the thread length 0.875 inch, which means it go to maximum already. When you rotate, it cannot translate anymore. All right, understand? So any questions? If no, shall I continue? So I just continue. All right. Close. File close. Don't save. Okay, next. So we have done this one. Okay, mechanical mate, gear mate. Okay, gear mate force two components to rotate relative to one another about selected axis. Valid selections for the axis of rotation for gears mates include cylindrical and conical faces, axis and linear edges. So what that it means? So I open my SolidWorks. So I just show you the assembly lah, huh? I don't want to do the assembly anymore, you know, very time consuming. Open. If you want to know how to do the assembly, you can ask me during the tutorial, no problem. You can ask me during the tutorial how to do the assembly because this one is not included in your syllabus, all right? Just for your acknowledgement. So gear, right? Okay, gear. All right. What happened? Gear pin. All right. So you see what happened now? When I rotate this gear will rotate simultaneously. You see what happened? You see? You see? Very nice. All right, very nice. I can even add a motor here. All right. This one is not included in your syllabus, but if you want to know how to do the assembly, you can ask me during the tutorial. Don't worry, don't be shy, you know, just come and ask. Bring it on, you know, bring it on. So let's say I want to add a motor here. I select this guy. Okay. Play from start. You see, very nice animations. All right. So find questions. If not, then I continue. Close, don't save. So this is gear to gear, mechanical mating. So next, what is the next? Okay, mechanical mate, rack, pinion mate. Okay, with rack and pinion mate, linear transmission of one component, the rack, causes the circular rotation in another component, the pinion, and vice versa. You can make any two components to have this type of movement relative to each other. The components do not need to have gear T. Okay, so what that it means, let me show you. So I open my SolidWorks. So file open, I just open the assembly. This is not included in your syllabus. I just show you for your acknowledgement. What happened? Browse file. Wait lah. Queue. Open. Queue pin. Yeah. Okay. Done. So let's see what happened. I hide the plan first and also the axis. So let's see what happened. If I move this rack or pinion, this is called pinion, this is called gear. You see what happened? Very nice, right? You see? Very nice. So far, any questions? If you want to learn how to do the assembly, you can ask me during the tutorial. I will show you step by step. But now we don't have enough time, you know. I just show you the assembly. Okay, so I close this one. Close, then save. So next, what's the next? Okay, next. Mechanical mate, hinge mate. Okay, a hinge mate limits the movement between two components to one rotational degree of freedom. It has the same effect as adding a concentric mate plus a coincidence mate. You can also limit the angular movement between two components. Okay, let me do the demo. Open the assembly file, that only you can understand, all right? So open, where is my hinge mate? Yeah, this one. Review, all right? So this is my hinge, all right? Yeah, you see what happened? When I close, right, this hinge, the top hinge will never touch the bottom hinge because I set the limit already. This one is same as the maximum distance setting. All right. And also the angle here. You see, if you turn only 180 degree. All right, really nice. Like this. All right. Okay, what next? Close. Don't save. Okay, this one universal join. I think you have learned. You have done this in your assignment number 2. Okay, in a universal join method, the rotation of one component, the output shaft about its axis is driven by the rotations of another component, the input shaft about its axis. So I will skip this one. And the last one, mechanical mate slot mate. I think this one you have done it in your last tutorial last week. Okay, this is very easy. You can make both to straight or arch slots, and you can make slot to slots. You can select an axis cylindrical face or a slot to create slot mates, such as this door buckle. Right, this is a very good example. Okay, I think we have done all the tutorial. The lecture notes already. 1 to 12, the end. So far, any questions? If no questions, right, then I will show you something. So, okay. I think we do need a break. Okay. Then no more online lecture anymore. No more already. And next Monday is holiday. Make sure you don't come. All right. And test 2 will be held on the 13th of June 2022, Monday, 2 to 5 p.m. All right. Where's the venue? I still don't know. I still wait for the university to give me the lecture room. And actually, I have posted 2 YouTube links in Times creating mirror part and thread. So here, let me show you here. You open your Times, right? Go to test 2. This one. One is the video, how to create the whole part in mirror, and another part is create the thread. By the way, Wendy, right? Wendy. Last week I have shown you how to do the thread by using the spiral. I think we don't. My advice is don't use spiral. We create a straight line as the path. Actually, it's included in this video. You can see my video. I just recorded last week, yesterday. You can see the video. I show 2 ways, all right? I show 2 ways. Just create a straight line path. Very easy one. You don't need to create a spiral anymore. Okay. And then, okay, for assignment 2 and 3, create PDF files for each of the part drawing and assembly drawing. Merge all the PDF file using this link. Okay, I post 2 times already. You can open the file. Okay, make sure put the assembly PDF file as a first page before merging. Okay, yeah, 1 question. Yeah, but using thread under whole widget can also write. Yes, can. Full marks. You will get full marks, don't worry. All right. For assignment 3, please prepare a report not more than 5 pages, free format. There's no format. All right. So have you formed your group already for all of you? Have you? And please email me your group details, your group member. Just email me who is the team leader, who is the group member. All right. And this week we will continue tutorial 7. I think I have posted 2 times already, tutorial 7. Hold on, tutorial 7. Tutorial 7. Yeah, I post already. Okay. And also the pub files. All right. Start from this week, please bring your own laptop, all right, with the latest version of SolidWorks, because all these platforms must be open using SolidWorks 2021. All right. So far, any questions? If no, then we just call it a day. Then we don't have any online lecture anymore. All right. So I will see you during the tutorial this week. All right. Thank you and bye-bye. So, okay, there's 1 question. So, sir, for chapter 12, everything is out of syllabus except advanced mate. Actually, slot is in your syllabus, you know. Slot is included. All right, slot is included. Only the gear, the what? Cam are not in your syllabus. Just now what I've shown you is only for your acknowledgement and entertainment purpose only. All right. So are you enjoyed to see the demo just now? I'm sure you enjoyed to see the demo just now, right? The cam, the gear, how to move, right? Yeah. Just to increase your knowledge. So next time when you go to work, right? At least your boss interview you, you can answer lah. Oh, I learned Solidworks before. I know how to do the cam, gear to pinion, how to move, universal join, you know. Yeah. If no question, then we just quit a day. All right. Thank you. Bye-bye. Okay. See you. Bye.